Hey guys, in this video we are going to talk about pKa values and how they can be used to decide the relative acid strength. So what we are going to take a look at is quickly what is pKa. Then we will talk about why do we need it, the why of pKa. And then finally we will see how to use it to decide the acid strength order. So let's quickly look at what is pKa. pKa is a concept which is very similar to pH. The only thing is, in the place of H plus concentration, we use the value of Ka. So as in pH, P stands for the power of hydrogen. Similarly, in pKa, P stands for the power of Ka. And as we know that pH is defined as negative of log of H plus concentration. Similarly, we define pKa as pKa equals to minus log Ka. So you can see in place of H plus concentration we are using the value of Ka. What that does is it takes the power of the Ka values and makes them simple decimal numbers. Let's take a few examples. Suppose Ka equals to 10 to the power 2 or 100. Then what will be pKa? pKa equals to minus of log of Ka. Therefore, it will be minus of log of 10 to the power 2. And because log gives us the power as the answer, so we will write pKa equals to minus of 2. Let's take another example. Ka equals to 2 into 10 to the power 3. Then pKa becomes minus log 2 into 10 to the power 3, and you can use the formula log of A into B equal to log of A plus log of B. So it becomes minus of log 2 plus log 10 to the power 3, and that gives us minus of log 2 is 0.3 approximately, and log 10 to the power 3 will give you 3. So the answer becomes minus 3.3. Let's say we have Ka equals to 10 to the power minus 4. Then pKa will become negative log 10 to the power minus 4, which is equal to negative of minus 4, which comes out to be 4. Now something very interesting is happening here. When Ka equal to 10 to the power 2, pK came out to be minus 2. So if Ka was 10 to the power 2, then pKa is minus 2. And when Ka became 10 to the power minus 4, we obtained the value of pK to be 4. Now look at what's happening here. Ka is decreasing in value, right? 10 to the power 2 means 100 and 10 to the power minus 4 means 1 by 10,000. So as Ka is decreasing, the value of pKa is increasing from minus 2 to 4. So we get an important information from here, that is high Ka means low pKa and low Ka means high pKa. Now in the previous video we related Ka with the acid strength. High Ka means strong acid. So a strong acid will have low value of pKa and a weak acid will have high value of pKa. Just like pH, where a stronger acid has low pH and a weaker acid has high pH. You can use this to decide the relative strength of acids. For example, if you have HCl and CH3COOH, which one of them will have higher pK value? So if you call the pKa of HCl as pK1 and for acetic acid as pK2, we know that since HCl is a stronger acid, it will have a low value of pK. So to summarize, order of Ka is the same as the order of acidity or acid strength, whereas the order of pKa is the reverse of the order of acid strength. Let's use this concept in a sample problem. Let's arrange these three compounds in the decreasing order of pKa values. So we have acetic acid as X, methanol as Y and phenol as Z, and we want to arrange them in decreasing order of pKa values. The first step to solve this problem is to find the order of acid strength. And you know that acetic acid is a stronger acid than phenol, which is stronger than methanol. If you have trouble deciding this order of acidity, watch my videos on relative strength of acids and bases and you will have no problems doing that. And now since we have the order of acidity, we can write the pKa order as the opposite of this value, and so we can write Y will have the highest pKa followed by Z followed by X, and that is the answer. With this video, we have covered everything related to acids and bases in organic chemistry. If you have any doubts, feel free to comment below the video and I will help you with that. In the next series, I plan to talk about isomerism. See you in the next video. Bye-bye.